Hi everyone, thanks for liking, commenting, subscribing, sharing, watching these videos. In this video, we'll discuss a topic named degree of dissociation from chapter chemical equilibrium. Very important topic. Degree of dissociation is written with term alpha. Okay, so let's start with this alpha. And what is meaning of it? Alpha is the amount in number of moles which is coming from 1 mole of given substance. So 1 mole loses how many moles? That is known as alpha. Okay, now to make it much more easier, I will take one example here. Let's say I write A gas becomes B gas plus C gas. And initially at time t equals 0, you carry 1 mole of A, 0 moles of B and 0 moles of C. At equilibrium, let's say out of 1, you have to write something, so you can always use alpha, because alpha is the number which is defined as, or which is has been defined as, that how many moles are coming out of 1 mole. So as you can say, we write 1 minus alpha. What will be the number of moles of B here? Alpha, and C is how much? Alpha. So just try to understand, like you can ask a valid question. Let's say the question is given like this, you have done this. What about if I get a question where the number of moles initially are not 1, and let's say it is A. So if it is given as A, then what should I do? So I'll say one thing. 1 gives alpha, so A gives how much? You can get that. A gives A alpha, so how much of B is formed? A alpha, because 1 mole of A gives 1 mole of B. So since A alpha moles are breaking, so you get A alpha moles of it. And you get A alpha moles of C also. So this is a simple thing that we can write like this. And once you complete this discussion, we will learn the concept of average molecular weight also linked with this. So I'm just creating a small space here, this side. So in this situation, let us learn what is average molecular weight. Right, so we can say initially how many moles of A we have? We have just 1 mole. So 1 mole of A multiplied by molecular weight of A should be initial mass of the thing, which is mass of A. But later 1 minus alpha plus alpha and plus alpha, total moles are these many, and we don't know what is the average molecular weight of the mixture. So I'm using word molecular weight unknown or molecular weight prime, okay, which is nothing but average molecular weight of mixture. So if you just look at this number, how much is MW prime coming up? It is coming up molecular weight of A divided by, now this gets cancelled, upon 1 plus alpha. So this kind of result we can get if you talk about molecular weight. So let's say I am writing molecular weight prime as M prime and molecular weight as M. Can we rewrite it as 1 plus alpha? And now 1 plus alpha is how much? M divided by M prime, and alpha is equal to M upon M prime minus 1. So all these things can be done, and we can talk about these components without any problems. Now next important part is, what will be answer for this question? If the number of initial moles are A, so can we say everything will be working in the same direction? The only changes are that this number, which is written as 1 into molecular weight A, would become A times molecular weight of A, or A times M, and later this should be equal to A minus A alpha plus A alpha plus A alpha into M prime, which is, if you solve this properly, A get cancelled. So M comes M prime upon, M prime comes M upon 1 plus alpha, or M comes M prime times 1 plus alpha. So this kind of result is again received with the same kind of calculation. So I hope this much should be very clear without any problem. This much we can understand. Now the question is, what is this vapor density concept? So remember, if you say relative density of 1 with respect to 2, so density of 1 with respect to 2 is written as d1 divided by d2. And what is vapor density? Vapor density is density of a gas ratio taken with density of hydrogen gas, okay, at same temperature and pressure situation, at same TNP conditions. So as we know that the density term, if you write, it is Pm upon RT. So what is the proof of this thing? We know PV is nRT. Number of moles are weighed by molecular weight, RT. So PV is W by mRT, right? So using this result, can we say, just simplify this. So what you can do is, D is Pm by RT. How can you get this? W by V is how much? Pm upon RT. And what is W by M? Nothing but density. because mass by volume it is, right? So d is Pm by RT. Can I use this thing for d gas ratio taken with d hydrogen ratio, which is same as, if T and P are same, they will get cancelled out. It becomes m gas upon m hydrogen. I think that's the simple outcome we can understand. And when you put it back here, it becomes m gas divided by m hydrogen. And what is molecular weight of hydrogen? It is equal to 2 units. So almost 2 units, 2 moles, sorry, 2 grams per mole. So what is the result? Vapor density of a gas is equal to molecular weight of a gas upon 2. So, or we can say molecular weight of a gas is equal to 2 times vapor density of a gas. So these kind of results we can solve. Now next question is about, like what do you say, average terms for vapor density or vapor density of the mixture. So the only difference is you have d prime, which is technically speaking m prime upon 2. So all those results of m prime will be applicable here. So as we have written this thing, I can write d upon d prime minus 1 also, which is d minus d prime upon d prime as the calculation, and they can give certain graphs or some other things based on this. I hope you understood what is meaning of degree of dissociation and what is the application of the same in chemical equilibrium. Thank you very much.